So good morning to all. So we are in the discussion of the different parts of the CRO. So in the previous class, we are discussed about the horizontal deflection system. So in the horizontal deflection system, so how we can produce the trigger sweep generator and how we can produce the trigger pulses, and also discussed about the time delay, generation of the time delay in vertical section. Okay, so in today's session we will see so dual beam and dual trace CROs. Dual beam and dual trace CROs. So, and before that we have one concept, that is synchronization selection for a continuous sweep CRO. So continuous sweep CRO. So here we have connection, how to connect the synchronization pulses to the horizontal sweep generator. So that is there are three position switches there. So which connects internal, external, and line. So from the input from the vertical amplifier is connected through internal position, and from the line, so that is from synchronous selector, that is from line supply, it will connect to the line position, and also you can also give some external signal from external position. So with these three positions, the synchronous pulses will be generated. The signals will be generated from these three modes of selections. Okay, like this, there is a provision for the in the horizontal section, so which connects the signal from the vertical amplifier, and which can also select the signal from line, and also selects from the externals. So like this, we can choose the signal according to that. It will produces the pulse signals, that is the trigger pulses it will generate, and those trigger signals will be sent to horizontal sweep generator. Okay. So these are different sections present in the horizontal deflection system. So like that, trigger sweep generator, trigger pulse generator, all these are will be present in the horizontal deflection system. Okay, whereas in vertical amplifier section we will have vertical amplifier and a time delay system, whereas in horizontal deflection system we will have so sweep generator, time based generator, and trigger pulse generators, and horizontal amplifier section. So here the horizontal amplifier section is also same as the vertical amplifier section. So horizontal and vertical amplifier sections are having same type of the construction, and inside we have pre-amplifier sections, driver amplifiers, okay, inverter amplifiers, as seen in the vertical amplifier. The in details of the vertical amplifier we have seen. So like that, the same construction for the horizontal amplifier also has. Okay, so and next coming to the dual beam CRO. Dual beam CRO. So it is a one type of the CRO. So there are a list of CROs are there. That is the dual beam CRO, dual trace CRO, sampling oscilloscope, storage oscilloscope. Like that, there are number of CROs are there. Okay, so out of that, this is one type of the CRO, that is dual beam CRO. So in dual beam CRO, so in this case, so here the name itself says that having dual beam, so it is having two beams, two electron beams. So there is a provision in the CRT that it is having two electron beams producing. So to it produces 2 electron guns. So it is having 2 electron guns and producing 2 electron beams, and 2 vertical deflection plates, 2 sets of vertical deflection plates, and 1 set of horizontal deflection plates. It is having 2 vertical deflection plates. This is 1 set of vertical deflection plate, and this this is 1 set of vertical deflection plates, and this is another set of the deflection plates. So 2 vertical deflection plates are present in dual beam CRO. So whereas coming to horizontal deflection plates, it is only 1 set of horizontal deflection plates, and it is having two main vertical amplifiers. So for each vertical deflection plates, it is having each vertical amplifier sections. Okay, so like this. Okay, so and these are connected to pre-amplifier and attenuators. Okay. The signals, suppose we have 2 signals has to be analyzed at a time. So signal A and signal B, 2 signals are applied for the two vertical amplifiers through pre-amplifier and attenuator and delay line. So signal A is applied to pre-amplifier and attenuator, and with this we can have the change the signal amplitude. Okay, so we can select the signal amplitude, and that will be applied to the main vertical amplifier through delay line. So through delay line, it will sense the signal to main vertical amplifier. Okay, and after the pre-amplifier section, the signal is connected to the trigger circuit through a switch. Trigger select switch is there. So what we have seen in the last slide, that is having a trigger selector switch. A switch is there, which is the switch will connect to either vertical input signal, the signal which is applied, and it will connect to a external signal, and it will connect to a line signal. So in this case, the trigger selection switch is connected to, so either signal A or signal B. So suppose we have to analyze the signal A. So in such situation, the trigger selection switch is connected to a point A. Okay, and due to that, the input signal is applied to the trigger circuit, and according to that, it will produce the trigger pulses, and those trigger pulses are applied to sweep generator, and sweep generator will produce the sweep signal, and that sweep signal is applied to the horizontal amplifier, and horizontal amplifier amplifies the applied sweep voltage, and that is applied to the vertical deflection plates, and according to the applied signal to the horizontal amplifier, so the deflection plates will be moved left and right. So it will, the horizontal deflection plates move on the left to right on the screen of the CRT. Okay, so in suppose now the signal is connected to signal B, and the signal is pre-amplifier and attenuated, and it in such situation the switch is connected to B. So in such situation, the switch is connected to B, and due to that, the same signal is connected to the main vertical amplifier through delay line. So the vertical amplifier will produces the corresponding anti-phase output signal by using the push-pull amplifiers, and that output voltage is applied to the vertical deflection plates. Okay, and due to this, it will be moves the screen vertically up and down. Okay, so like this we can analyze the signals which are applied on signal A and signal B, and in this case we have 2 separate vertical amplifier sections for the 2 separate signals, and having single sweep generator, that is single time based generator. Here we have single time based generator for the two signals. For two signals, it is having single vertical section, single time-based generator. So whereas in the vertical section, it is having for each signal, it is having one vertical amplifier. Okay. So suppose we have to connect these two signals. So okay, signal A and signal B, and at a time we can analyze. Suppose a signal A is applied to signal A switch, and another signal is applied to signal B, and this trigger switch is connects to A and B. Okay, so it will be switch will be connects for the A for some time, and after the B it will connect for some time. So like this, the same trigger pulse is applied uh, for the two signals. Suppose suppose we are connected switch to A, and we will get some output waveform. So that output waveform we can lock on the screen. So now the switch S is connected to B. So in this situation, it connects the signal B, and due to that, it produces the signal B output, and these two signals will be analyzed because they both are having same time generation, and frequency is should be same. So that's why we can analyze the both the signals amplitudes in the same screen. Okay. So if you see this, so here we have a difference between dual trace oscilloscope and dual beam CRO. Dual scope oscilloscope, dual trace CRO, and dual beam CRO and dual trace oscilloscope. So dual trace oscilloscope is having one cathode ray gun and an electron switch will present. That switch changes its signals to single vertical amplifier. So whereas in a dual trace oscilloscope, having one single vertical amplifier section and having an electronic switch. That electronic switch is connected to the vertical amplifier, and it will connect the two signals to a single vertical amplifier. Whereas in dual beam CRO, we use the two separate vertical beams, two sets of vertical deflection plates and a single set of horizontal deflection plates. Okay. So only one beam can be synchronized at one time, and since the sweep is the same for both signals, the common time-based signal is used for both the signals. Therefore, the signals must have the same frequency or must be related harmonically in order to obtain both beams locked on the CRT screen. For example, the input signal of an amplifier can be used as signal A, and its output signal is as signal B. Suppose we have to get the difference of the amplitudes of the input and outputs of a given amplifier section. So for that, the input which is applied for the amplifier is applied to input which is applied for the amplifier is connected to signal A, and the output of the amplifier is connected to signal B. So then we can both the signals is applied to the dual beam CRO, and from that the frequency, the obtaining frequency is same because we have a single time-based generator for both the signals, and we can differentiate the amplitude for the amplitude for the input signal and amplitude for the output of the amplifier can be observed by two separate vertical amplifier sections. Okay, with this we can differentiate the displayed output is produces Suppose so this is the input for the amplifier, and the output is definitely it is the amplitude increased. I mean signal amplitude is increasing and frequency is same. The frequency is same, but amplitude will be increased because the gain of the amplifier purpose is to increase the strength of the signal. Okay, so like that we can produce the same frequency. Okay, frequency is same for both the signals, but there is difference in the amplitude. So that difference in amplitude can be measured by using the this dual beam CRO by applying the amplifier input and output for the dual beam CRO. So this is the amplifier having some gain, and this is the input, and this is the output. The input is connected to signal A, and output is connected to signal B. The other terminals are connected to ground. Okay, so so here I am applying some sinusoidal signal to the amplifier, and we can measure the output through output of the amplifier through signal B. So with this we can produces the output. Okay, input and output signals can be analyzed for the same CRO. So the amplitudes which are measured, this is the input for the amplitude of the input signal, and this is the amplitude for the output signal, and A0 is the output for the output signal, and AI is the amplitude for the input signal. So the same two figures can be obtained on this CRO stream. So these two signals can be from this output or display of the CRT, we can measure the two gains, amplitudes or peak values, and from this we can find the gain. Gain is equals to output by input. So A0 by AI or AI. Okay. So like this we can analyze the amplification of the particular given amplifier section. Okay. So with this we can analyze the gain, and from that we can also obtain the border plots. So after obtaining this gain for different frequency signals, suppose we are changing the frequency. Suppose we are changing the frequency of the input signal from one frequency to another frequency. Suppose 0 to 1000, 0 to 1k hertz. So what is the gain? And from 1000 to 10,000, what is the output of the signal? And from that we can calculate the gain, and with that gain we can produce the voltages, the gain in terms of decibels, in terms of the decibels. So with that we can analyze the gain of the given section or amplifier, so using border plot diagram. Okay, so like this we can analyze the analysis in the frequency domain. So we can analyze the frequency analysis by using border plots after obtaining the voltages from the CRO. So like this we can analyze. So the next one is this is about the dual beam CRO, and the next one is dual trace CRO. So this is the plot diagram which illustrates the different sections which are present in the dual trace oscilloscope. So in this we have a single vertical amplifier. We have a single vertical amplifier, and a electronic switch will be present. Electronic switch will be present. This electronic switch will be connects the two channels. Here we can observe the channels A and channel B. Two channels is connected to two different input signals. So with this we can connect it to two input signals, and those two input signals can be analyzed using this dual trace oscilloscope. So here channel A is connected to one signal and channel B is connected to some another signal, and those should be preamplified and attenuated. Okay, and that signals is connected to the electronic switch through delay line. So for each section we have delay line, but these two channels are connected to a single vertical amplifier. So whereas in dual beam oscilloscope, so each channel is connected to separate vertical amplifiers, whereas in dual trace oscilloscope we have only single amplifier, single vertical amplifier. Okay, so whereas before connecting to the signals to vertical amplifier, so we have a electronic switch. We have an electronic switch. This electronic switch is connects the both the signals. Electronic switch is connects to both the signals. Okay, so we can operate this dual trace CRO in two modes. So one is alternate mode and another one is the chop mode. So one is the alternate mode operation and another one is the chop mode operation. So in the alternate mode operation, what happens? So this electronic switch is connects for one sweep to one channel, and for the next sweep it connects to channel B. So here we have the single time based generator, so sweep generator and a trigger circuit. So there is a provision that when the switch is connected to channel A, so it should connect to trigger circuit should be connected to channel A. If the electron switch is connected to channel B, and trigger circuit will connect to the channel B here. Okay, and like that there is a in the alternate mode the switches will be changes. Okay, so suppose assume that in the first the trigger pulse is producing. Okay, and the first sweep is generating. Okay, so when the first sweep is generating, the switch is connected to channel A, and the channel A signal is connected to vertical amplifier. So in such situation, the vertical switch electronic switch is connected to channel A, and that signal is connected to vertical amplifier, and the vertical amplifier produces the amplitude. Okay, so after that the switch generator will produces the retrace period, and after that again it is having certain hold period, and again it will be rises and it will produce the sweep signal. So at this moment, it when it will be comes to minimum value, the electronic switch is connects to channel B. The electron switch is connects to channel B until it produces the peak value, and again the sweep generator will produces the retrace speed and it will be stand somewhere. So when this will produces this particular peak value, again the switch is connected to channel channel A. So this is the channel A input to vertical amplifier, and this is the channel B signal to vertical amplifier. Similarly, this is channel A, and this is the channel A. So and next one, next sweep starts. Again, it will connect to the channel B. Okay, so ఎప్పుడైతే మనకి ట్రిగ్గర్ సర్క్యూట్ స్వీప్ వోల్టేజ్ జనరేట్ చేసి స్టార్ట్ అయిందో అప్పుడు ఈ ఎలక్ట్రాన్ స్విచ్ అనేది ఛానల్ ఏ కి కనెక్ట్ అవుతుంది. అప్పుడు ఎప్పుడైతే ఇది ట్రిగ్గర్ సర్క్యూట్ పాజిటివ్ స్లోప్ సో పాజిటివ్ స్లోప్ ప్రొడ్యూస్ చేస్తుందో, సో అంటిల్ దట్ పర్టికులర్ generation of the time sweep period, until the sweep period, so the electron switch connects to the channel A. So after that the signal is discharges, it means retrace period, and after that is having some hold time. Okay, so after that hold time, again the trigger circuit or sweep generator again produces the linear sweep to the period of TS. Okay, for a period of sweeping period. So again when it will be starts the next sweep period, starting of the sweep period, it will again connects the sorry, so when it will reaches the peak value, it connects the next channel, that is another channel B. Okay, so up to this point the channel B is connected. So again the sweep will be, the sweep voltage will be decreases and holds certain period of time, and again the sweep starts, the sweep period is starting. So at that time, up to that time, again will be connects to channel A. Up to reaching the maximum value of the sweep, it disconnects the channel A and connects the channel B. Okay, like this. So depending upon the sweep generator voltage producing of the sweep output voltage, this electronic switch will be operates or connects between two channels, channel A and channel B. సో ఇక్కడ ప్రొడ్యూస్ అయ్యేటువంటి ట్రిగ్గర్ పల్సెస్ స్వీప్ వోల్టేజ్ బేస్ చేసుకుని మనకి ఈ ఎలక్ట్రానిక్ స్విచ్ అనేది ఛానల్ ఏని ఛానల్ బిని కనెక్ట్ చేస్తూ ఆ యొక్క వోల్టేజ్ ని వెర్టికల్ యాంప్లిఫైర్ కి కనెక్ట్ చేస్తాం మనం. ఓకే, సో అది ఎలా అంటే ద స్వీప్ వోల్టేజ్ ఎప్పుడు when the sweep voltage reaches the maximum peak value, it will disconnect the one channel when and until to reach the next peak value. Until to reach the next peak value, it will be connects to the channel B. After reaching this peak value, it disconnects the channel B and connects the channel A. It connects until the next peak produces, peak voltage will produces. After that it disconnects the channel A and connects the channel B. It will be produces, it will connects until B, the next sweep or peak value is produces. Okay, so like this it connects the electronic switch connects the both the channels A and B, and it will be applied to the vertical deflection plates. So how the sweep voltage is producing from sweep generator is applied to the horizontal amplifier, and it will connect the horizontal deflection plates. Okay, so like this for some time of the sweep, for a period of sweep, it connects the channel A, and next sweep period it connects the channel B. and after coming next sweep, it connects the A. So alternately it will connect the both the signals. So like this, it will produce as the two signals. Okay, so that this is nothing but the alternate mode of operation. This is alternate mode of operation. So in the next mode of operation, that is the chopping mode of operation. So chopping means cutting, chopping. So make it is a small parts. So chopping of the signal. So here it will connect the two signals with a small amount of the for a small amount of period of time. Small amount of period of time it will connect the for both the signals. So here in this chop period, in the chop mode of operation, the electronic switch is connects for a small period of time with channel A, and it connects the small period of time with the channel B. Okay. Okay. So in this case, the electronic switch is produces a small chopping frequency. So with that chopping frequency, it connects channel A and channel B. It is in chop mode operation. The operation of the electronic switch is independent of the time based generator, the trigger circuit. Okay. In the previous case, the electronic in the alternate mode of operation, the electronic switch is connects to each channel A and channel B based upon the triggering pulse. Okay, based on the triggering peak value, trigger pulse or sweep generator output. Okay, so whereas in chop mode of operation, so the connections between the channel A and channel B is independent of the frequency generated from the sweep generator. So it is having certain amount of frequency, and according to that frequency it will be operates, and at that frequency it will connects the channel A and channel B, and it will be applied to the vertical amplifier section. Okay, and this is sweep generator will produces the its own frequency. Okay, its own frequency. So that we'll see in the diagram. So how these two modes of operations will be done. So here we have a two modes of operation, alternate and chop mode. So this is the in the alternate mode of operation. So the sweep generator produces the sweep voltage for a period of 100 microseconds of sweep period. Okay, and after that it is having retrace speed and hold time. Okay, so after that again the sweep will be starts for the first sweep period after reaching the peak value. So the electronic switch will be connects up to channel A. So after that the electronic switch disconnects the channel A and it will connect the channel B until the next sweep is produces its peak value. So after reaching the peak value, the up to that the channel B is connected. So next when the sweep voltage reaches the peak value, the electronic switch will be disconnects the channel B and connects the channel A. So like this we can have the two channels will be connected depending upon the sweep period of the time based generator. So for this sweep period, channel A will be connected. For the next coming sweep period, the channel B is connected. For the next sweep period, channel A is connected. Like this, the signals are connected and produces the output waveform. Okay, this is in the alternate mode of operation. In the chop mode of operation, the electronic switch will be operates at a frequency of 100 to 500 kilohertz of frequency. It will be it's like a free running switch. Okay, so 100 to 500 kilohertz frequency, it will be moves, produces the oscillations, and according to that it will connect the both the signals, channel A and channel B. Okay, you see here, so this is the here this is the time based generator sweep voltage. So whereas the second one is uh, the electronic switch will be uh, connects the channel A and channel B with a small frequency, with a small time period, with a difference of small time periods. So suppose this is the channel A. Channel A is connected this much of time period. Okay, so depending upon the chopping frequency of the switch, it connects this amount of the period of channel A, and after that it connects the channel B this much period of time, and again it connects the channel A this much period of time, and again it connects the channel B this much period. So like this, for a given period of chopping period of the electronic switch, so it connects the for a period of small period of time channel A, and it connects the small period of time channel B, and this is the at that point of connection period of time how much voltage it is there. So that is applied to the vertical amplifier, and amplifier will be amplifies that voltage and connects to the vertical deflection plates. Okay, so like this depending upon the frequency of the signal, chopping frequency of the electronic switch, the it will produces the voltages. It will connects the two channels to the vertical amplifier. The electronic switch will connect the two channels to the vertical amplifier depending upon the switching frequency of the chopping frequency of the switching circuit. Okay, uh, here it is electronic switch. We can use the electronic switch. Okay, so like this it will produces a small period of signals. If the flow rate, if the chopping frequency is very high, if the chopping frequency is very high, if the chopping rate is very low, so for then we can lose some signals. In such situation, we can go for the alternate mode. Okay, and another mode of operation is also there. So here we have another mode of operation, that is XY mode of operation. So this is the XY mode. So when we are operating XY mode of operation, this switch is connected to XY mode. Okay, and the time